welcome our next speaker, still from Nagaro, but talking in a bit of a different area now. Hello.
Hi. Let me just switch my camera because
Sure.
you see it's not the right one.
Yeah, now
Cool.
is the right one.
Now I'm with you. And hopefully I'm also audible. So I'm doing this
Yes.
kind of COVID test. Am I audible? Right? Cool.
Yeah. Some of the old trauma.
Yeah. We are still there with the online meetings.
Yes. So glad to have you here on the AI stage.
Thank you for
And
the
I know you have a
invitation.
lot of experience and expertise on this area. You focused a lot on these topics in the last time.
Yeah, I have, let's say, um, not just a professional interest, but also a hobby, right? So, yeah, maybe I have a point of view on this
Yes.
domain called AI.
And probably a lot of people will benefit from this topic.
I'm sure, definitely. So, you see, we are in this AI era. I think we are in the AI era since 20 years ago, right? Just that it wasn't that accessible for everybody, right? And nowadays, having these online free services, AI services, yeah, we can interact with it. So yeah, it's much easier to, I don't know, construct, let's call an experience, right, with AI. But hopefully, during my presentation, I will debate that a lot and just I don't know, convince people to take a step back, right, and think more on the journey to get there, to use AI in an efficient way. So having
I
this
think the stage
said,
is yours now.
yeah,
So you can
I think
just
I can
hit
share my
it.
screen.
Yeah.
Cool. Unfortunately, I have only one screen right now, but
I
because we
will
don't
help you with that.
see cameras and so if a question is coming on the chat, just interrupt me and we will address that question.
Yeah, I will help you.
Okay, let me share my screen. Hopefully I won't have IT issues. I already have IT issues. I managed to start the presentation, but not to share the screen.
The first part done, not the second part.
Yeah, let's see now.
Yes.
So, is it visible?
Yes, we can see the slides.
Cool. So, um, in today's session, I want to discuss about AI in general because what I've seen so far in the past few years, I think 3 or 4 years ago, everybody's starting to discuss about AI. But unfortunately, if you take a look on all the organizations, they are discussing only about generative AI, right? And how generative AI can be used in order to solve their problems. So somehow this model became a golden hammer, right, for all the problems organization might have, right? So they want to solve everything with generative AI. But you will see during this session that AI is not just about generative AI, right? So AI is more than that. So let's start the session. Um, First of all, short introduction about myself. So I'm based in Sibiu, Romania. I'm part of the Life Sciences Business Unit in Nagaro. I'm father of two daughters and the proud owner of, I don't know, many consoles. So this is one of my hobbies to play a lot of games. Good. Then let's see the agenda. So in today's presentation, we will discuss about AI use cases just to have a broader understanding where AI can be used and what kind of problems AI can solve, right? And then we will also understand that there are many other ways to apply AI and many other type of AI models beside generative AI, right? And then we will discuss about data, because data is the base for AI, right? Without data, you cannot do AI. Yeah, it's a false impression that, I don't know, going to ChatGPT and doing some prompt engineering there, very good prompt engineering, suddenly generative AI, which is behind of ChatGPT, will solve your problems without giving some data, some additional data. Then we will discuss about data quality, and hopefully we will have a good awareness on what is quality when we discuss about data. Then how the data quality is impacting AI. um, Following that, we will see how we can process data so we get our data ready for AI. And finally, we will evaluate together how an entire organization can prepare for the AI adoption. Okay, let's see some AI use cases. So AI can be used in, I would say, all the industries, right? So there is no limitation there. Like for instance, in healthcare, I don't know if you know, but already AI, it is used, for instance, in diagnostics, like when you have an X-ray of your, I don't know, internal organ, then AI, it is used to do image segmentation there to identify issues with your organs, or personalized medicine. So right now, there are a lot of healthcare applications even on your mobile phone. So your mobile phone right now can be considered a medical device, right? And there you can benefit from different treatment plans, and most of those plans are managed by AI. Then, of course, drug discovery, where AI, it is used in order to identify new type of molecules or proteins, to depict interactions between those in order to generate new drugs, right? Drugs that might, I don't know, help you for different illnesses. Same in finance for fraud detection. I don't know if you had this kind of experience, but last year my card was just blocked by the bank because the engine depicted a strange behavior on the way my money was spent, right? So then instantly my card was blocked in order to avoid, I don't know, someone taking my money. So this is done with AI assistant, with analyzing your patterns of spending money, right? So then when it sees some anomalies there, will block your card, right? In retail, for instance, I'm sure you know about those recommendation systems when you are looking for a product, yeah, using cookies or other techniques. That site already knows about your preferences, right? And suddenly when you go to, I don't know, also other systems like Facebook's, or I don't know, even Google, you will see a lot of advertising with some recommended product for you. Yeah, but sometimes we also saw that the engine doesn't really work, because if you look for a chair, then for one entire month, yeah, a lot of chairs will be recommended to you. In manufacturing, one very important use case is predictive maintenance. So without AI, this it's quite difficult to achieve, because applying just some, I don't know, a rule-based engine, it will be quite difficult or even impossible, yeah, to depict the remaining useful life of your devices or components. So AI plays a major role in predictive maintenance, or for instance supply chain optimization, like for instance the way you consume your stock, right? Or the way you acquire material in order to manufacture your product. That can be also optimized using AI. Let's see some other well-known industries, like for instance transportations. So in transportation, we know this use case of autonomous vehicles. Right now, there are many cars developed in the market, saying that they can do self-driving. Right now, we don't have all the laws and regulations in place in order to allow that, but I'm sure in near future we will see these kind of cars on the roads, and of course this won't be possible without AI. In education, we will see a lot of, I don't know, use cases where personalized learning will be offered. So AI can depict the patterns in which you are learning, and it can offer personalized content for you. So I don't know, you can advance much faster in acquiring some knowledge. In entertainment, we already saw AI a lot in game development, like your NPCs are smarter and smarter, right? And also in content creation, we saw how AI can generate music. Like for instance, there are some games where the music is adapted to the way you are playing the game, right? So this is acquired through AI. Now, in security, of course, there are some very important use cases that can be covered, or can be, I don't know, problems from those use cases that can be covered and solved with the AI, like threat detection, yeah, to detect, I don't know, some attacks, yeah, before they get to the point you cannot defend anymore. And I'm sure you already saw these biometric authentications, like for instance, face recognition or fingerprint scanning. So behind of those, there are a lot of AI models, right? So as you can see, AI can be applied in many domains, right? And as I said, it can be applied, I think, in all the domains. Now, behind of this is not only generative AI, right? There is a lot of different models, like for instance, I don't know, computer vision models, right? Models that are capable to interpret an image and depict what is inside of that image or video. There are models capable to do forecasting. Like without forecasting and predictions, it's quite difficult to achieve predictive maintenance. Then there are models who can, I don't know, do classifications, like for instance in recommendations engines. When you look a specific product, then that product belongs to a specific category, then automatically some other product from those categories, and also based on your profiles, will be recommended based on some classifications, right? So there is a broad area of models, right? And the ecosystems is huge. And yeah, in the past, these kind of models were quite difficult to, I don't know, to be integrated because of hardware limitations. But nowadays is yeah, much easier, right? We have access to a lot of power, right? So we can definitely benefit from this kind of models. But there is one aspect to these models. It's about data. So there is no model right now in the world that, I don't know, works without training, right? I'm not aware of any model right now in the world capable to either do some prediction, either do some classifications or forecasting, or even this chatting kind of models without being trained. And to train a model, you need to have a lot of data. Like for instance, for ChatGPT, we all know that to reach this state, trillions of tokens were used to train that model. What means tokens? Tokens can be, for instance, words, or for just to predict the remaining useful life of a specific system, yeah, in manufacturing, you will need billions of events to be captured during years in order to train a model to understand the patterns which are behind of the system behavior, so then you can predict and forecast the remaining useful life. So data is very, very important. And what I've seen from discussions, people, they don't talk about data that much anymore. Yeah, they concentrate a lot on, I don't know, how we can develop fast using generative AI, how we can do a better prompt engineering in order to get more and more from generative AI. But when they start the journey, when they start to use this kind of technology, they will first discover that they won't take that much out of the system, because if you don't put data into the system, then the system cannot give answers which are, I don't know, tailored based on your very specific needs. Having this said, and having this awareness on data, and that the fact that data is needed, let's see what is data. I'm sure you all know what is data, but also based on my experience, when you say data, most of the technical people are thinking on tables, right? But data is more than that. And data is grouped in different categories. And I will tell you few of the categories. So when you discuss about data, right, then you can also think on these categories. It will be much easier to identify, right, what use case applies to that very specific data. So data starts with raw facts, right? So what are facts? Facts are just information which is there, right? And it's a truth. Like for instance, if you go to Wikipedia and you ask for, I don't know, questions related to population demographics, right? Or questions related to website traffic, or questions related to product sales, and then you receive very specific answers, right? So these are facts. Then we have figures. Usually figures are values indicating numerical values indicating the state of a specific, I don't know, problem, or the state of a very specific business situation. Like for instance, you have figures for financial data, which usually are numbers indicating, I don't know, money, and usually revenue or expenses. You have figures coming from educational data, like for instance, how many students you have, and so on. Now, beside data which is, I don't know, quantifiable, and is it has a number behind, or it has a fact behind, you also have images. We all know, right? And we saw that more and more models are capable to work with those, with images, even translate text to images, right? But a lot of images were used in order to train those models, right? So images is also a type of data. Then you have documents, right? And here you can include, I don't know, digitally created documents, or even scanned books, or hand written documents, right? So any type of document which doesn't have necessarily to contain structured data inside of it, but they have information. And then you have audio. I don't know if audio is working here. I just created a mix of sounds. I won't start in them also for the interest of time. Then you have other categories regarding also to the domain where the models can be used. Like for instance, you have time series, and time series are just events in time, right, which are captured, and this can be used in order to forecast and predict. Then you have categorical data, you have spatial data, which indicates position in space. Then you have hierarchical data, and this is quite useful, for instance, for classifications. And then you have graph data, right? And maybe you heard about um, knowledge graph. Right now it's, I don't know, it's buzzword around data, right? So knowledge graph, it's nothing else that terms which are in a certain relation, right? And in a graph you model all those terms with all their relation. Now, even if you collect data and you have a lot of data available, if the quality is poor, yeah, you cannot use it. And the quality of data can be, I don't know, measured with some KPIs. Here I present five of them. It's about completeness, consistency, precision, relevance, and accuracy. But there are many others like validity, integrity, timeliness. Um, but for the interest of this presentation, we will focus on only on these five, because data quality is very important, right? Like for instance, if you don't have complete data, right, you might miss event points in your data set, and your models won't be able to depict useful patterns, yeah, useful behaviors from your data, right? So it's very important your data to be as complete as possible. Now, regarding accuracy, if your data is not accurate enough, again, this will impact your model and the outcomes, right? And for this, you usually measure the error rate and the validation error rate for your data. Then consistency is also important. Like for instance, if you have a lot of data, but you take a look on the data and then you see that you have a lot of duplications there, right? Then that volume is not important anymore, right? Because you will have a lot of garbage inside there. You will have a lot of duplications inside there. So you cannot really use that data. Usually AI models require a high variability in your data in order to really depict patterns inside of it. Precision, of course, if your information is not precise, right, then your model cannot learn. And here, as an example, is the decimal accuracy. If you don't have a good enough decimal accuracy on your data, then maybe your financial figures, right, will be quite impacted, right? Then relevance is not enough to have a lot of data, but that data have to be also relevant for you, yeah, for your use cases. Like I can give an example. One company a few years ago asked me, we have a lot of data, can you tell us what to do with it? Well, maybe yes, but it's much better to have a lot of data which is relevant for you. Yeah, you already know how to use it. Then data, as I already mentioned, the quality of data definitely impacts AI, right? And the AI models. And usually the impact is on these attributes. So accuracy is highly impacted on your models if you have poor quality data, because you already know this. garbage in, garbage out, right? So the model will be capable to return information that was seen during training. If you put garbage during training, you will get garbage during inference, which is called the moment when you use the model to predict or classify. Then reliability. As also Thomas said, it's very important user to trust, the system they use. Now, if uh, your model receives poor quality data as an input, of course, the quality of the output will be quite impacted, and the user won't trust that output. I'm sure they won't trust even the input if it is poor quality, right? Then generalization. If you don't have a good distribution of examples in your data, right, um, your models might get overfitted, which means they have a very good accuracy and performance just looking on that very specific data, right? But when you give examples that were not seen during training, right, the model won't be capable, right, to predict, because it was overfitted only for the data seen during training. And usually this is happening when you have um, less amount of data and also less amount of variations in your data. Then performance is also impacted. I already mentioned this. Bias mitigation is a very important aspect. Like for instance, if I train my model only with cats, when I will show a dog, the model will tell me that dog is a cat, right? Because it has a big bias, right? He knows only about cats. And last is cost and efficiency. If your data is not a good quality data, then you have to spend a lot of time to clean it, right? And here I also constructed, let me move this one, I don't know if you see it, okay. I constructed a matrix um, where you can see how data quality can impact the performance of the models. And what I discovered is that in most of the relations between impact, sorry, and data quality, we see high impact, right? So data quality is very, very important for the quality of your models. Usually, better data, it's much better to have comparing to better algorithms, right? So good data, it's much powerful than any fancy algorithm you might have. Now, we all know that in order to create AI models, you have a few phases. One important phase is the data engineering phase, right? And in data engineering phase, we have few steps we have to follow. One is data collection, when you collect all your data inside of the organization. Then you clean the data, right, in order to enhance the quality of it. Then you transform and normalize the data, because you might have there different type of measurements, right, inside of data. And then you want, I don't know, to always add apple with apple and not apple with bananas, and so then you have to normalize the data. Then you do feature selection and feature extraction, which means you select only those parts of data which are quite relevant for your model, right? And you eliminate the garbage out of your data. And then, of course, you do the model creation, you design and train your model, then you optimize the model, and at the end, you evaluate the quality of it. Um, Data collection, usually, it's a long-running process. This can take, I don't know, years, right? It's not like tomorrow I decide to collect data, I collect data, and the day after tomorrow, I just use that data, right? It's usually takes years. And data collection can happen either coincidentally, right, or proactively. Of course, the best way to collect data is proactively, because this means I collect data strategically. Yeah, I know what I want to solve, I know what kind of answers I want to receive, and then I collect it proactively, right? Data cleaning, as I mentioned, it ensures that your data is structured, right, according to your business needs. Then transformation, normalization, I already explained that. And of course, feature selection and extraction, just prepare the data for your model creation. So these are most important processes to follow in order to have good data for your model creation, right? Um, Here I also captured some um, technical aspects on how you can get data for I don't know, for designing and training your models. Now, on premises, this is pretty straightforward. I'm sure most of you know this. You have data sources, then you have an ETL system where you extract data, right, and transform the data. Then you have a data warehouse when you store clean data inside of it and structure data. And after that, you can use the data, I don't know, in analytics or train AI models. In cloud on Google, this is a referential, this is a reference architecture. The concept is the same. You have data ingestion like ETL on premise. You have data processing where you clean, transform the data. Then you have the machine learning part, and later on, I don't know, insights analysis and so, right? And here, this is a reference architecture proposed by Google. For AWS, same, exactly the same concept, just that technologies are different, but each technology will do exactly the same thing. Like for instance, you have Redshift, right, which helps you to design and create a data warehouse. Then you have AWS Glue in order to put in place ETL services. So all in all, is exactly the same thing, just that you have different other technologies. And for Azure, recently Microsoft developed Microsoft Fabrics. And this is in fact a collection of many technologies that can help you to collect data, clean the data, and later on make that data available for further analysis or train models. And this is quite easy to use. And yeah, I congratulate Microsoft for doing like this, for doing this though. Now, um, even if you have data, you collected data, you put in place your infrastructure in order to collect and manage that data, there is also a very important aspect regarding how organization is treating data, right? So an organization which doesn't have a good maturity level on data management practices, right, later on will fail, because it will get in a situation where data, even if it is collected, it doesn't know exactly what to do with it, right? And because of this, I want to discuss also about maturity level in data collection and data quality. And there are some key parameters you can look on them in order to depict if you have good maturity level and if you have, as an organization, enough, I don't know, processes and things in place in order to ensure that all the data you collect, it's a good, valuable data, right? And the most important one, and the first one, is data governance. So this one ensures that you have policies in your organizations, you have frameworks and procedures. Also, you have the roles defined, like for instance, DPO role, right, in your organization, and you also have a data accountability mechanism implemented, which means there is an entity which is accountable for data collection in your organization, right? So data governance is very important to be instantiated in an organization. Then we have data management processes, and this is about how you standardize data, how you collect data, how you store the data, how you integrate other source of data inside of your organization, and also what is the data lifecycle, right, inside of your organization, how you archive the data, right? These are also very important. So later on, when you decide to adopt AI, you know that you have data available there. Then it's about data quality standards and metrics. Like I mentioned, and I will repeat, data quality is very important. Just having a lot of data in your company helps, but not that much, right? You have to have a lot of quality data in your company. And in order to depict if your quality it's a good it is at a good level, then you have to have in place standards and metrics. Otherwise, you cannot measure if the data quality is good enough or not. Then you have to have data acquisition strategies. Without a strategy in place, I will remind you, doing proactively, right, and strategically, you will just collect data by coincidence, right? So you have to have a data acquisition strategy in mind, focusing the business needs you have, focusing what kind of AI you want to adopt. Then it's about data integration and interoperability. Usually organizations, they have multiple departments and they have multiple generators of data inside of the organization, right? Now, if each department is working in a silo, right? Um, that doesn't help that much, because either you will collect redundant data. Imagine that two different departments, they just collect similar data, right? And then we came to that problem with the data quality regarding duplicated data, so consistency, right? um, Either those departments without talking each other, right? Even if they want to solve the same business problem, and having the data collected separately, right? That data isolated in silos won't be good enough to solve that business problem, but together, right, it is enough to solve that problem. So integration and interoperability is very important in an organization. Then you have to have an entity which is doing data quality control. So even if you have the best processes in place, you have the best policies in place and strategy, if you don't have an entity which is doing control, right? Based on my experience, none of the processes, none of the policies won't be really followed. Yeah. So you need an entity which is doing some policeman work inside of your organization, right, in order to check that everything it is followed, and the quality, the desired quality level is reached. And last of all, it's organization culture and awareness. So when I discuss about organization and how the organization is preparing for data collection strategy, it's not about only on, I don't know, selected people from that organization which are managing the processes, right? It's about of each individual inside of that organization, because we all produce data, right? And if we don't have an awareness on all the processes and the standards which are, I don't know, defined inside of the organization, right? We will collect as an individual, we will collect data just using, I don't know, by coincidence, right? And we won't collect and store the data strategically. Okay, now there are also some levels of maturity you can, so that can be used in order to measure, yeah, the state of the organization. where is the organization right now? Yeah, and then um, Gartner, for instance, proposed 6 levels, right? There are also many other entities proposing different type of levels, but I just choose Gartner because, yeah, I'm very close to those, right? So you have levels 0, which means you are unaware about data quality. Yeah, you don't know nothing about it, and you have no awareness on the need of the fact that you should collect data, right? There are many companies in this level, even if they don't admit, right? um, because I've seen organizations, right, which have data and they don't know how that data get there, right? So by sure they are at level 0, they are unaware about data collection. Then level 1 comes when you have a certain level of awareness. In this level, the organization is already starting to collect the data in a warehouse, right? So this means some clinic processes are in place, but not necessarily in a very standard way, right? Just it's just the awareness that we have to store the data somewhere in a central place. Then we have level 2, which means the company is uh, reactive. Here we have a central data repository, but still the data is collected just because it has to be collected, right? It's like when the data is produced, we will collect it. Yeah. Yet here we still no have a strategy. Then we have the level 3, which is proactive. Now, at that level, the organization already has a strategy on how the data should be collected, how the data should be stored, right? In order to later on enable some, I don't know, AI models on top of that data. At level 4, the organization is managed, which means all the aspects, all the key parameters that were mentioned before are in place, right? The processes are there, the standards are there. There is an entity which does control, and there is also a culture and awareness inside of the organization. And level 5 is very effective, nothing else to do. So I've never seen an organization at this level. I know I have only 3 minutes more and also one slide. And what I did was to combine the key parameters with the levels proposed by Gartner and create a matrix that can be used by organization in order to measure their level, identify at which level they are, and also some guidance on how that level can be achieved. But I don't have enough time to go through all of these recommendations. Yeah,
Thank you,
ready
Jeppy.
for questions and maybe some answers.
Yeah, let's see if there are any questions on the chat. I think people were interested because they were very silent and just paying attention to your presentation.
Yeah, hopefully, because they have to be aware that without having data, you cannot do really AI. You can play with ChatGPT, you can play with DALI, and so, but you won't solve real business problems, right? So you need to have data.
Hmm. So yeah, the importance of data, I think it's getting more and more important, and also as you mentioned with the sanitization and the quality of the data.
Yeah, and you have to start as soon as possible because otherwise you will just hope, to benefit from, I don't know, AI, right? You won't. Maybe you will benefit, like for instance, face recognition. Yeah, you don't need that much data to have face recognition in your organization, or I don't know, some assistant who can fix your email, right? but you won't really solve business needs. Like for instance, few years ago, I had a meeting with someone from Microsoft, and that person told me that they don't do manual budget anymore. The budgeting exercise is done automatically using AI, right? That's
Yeah, if
not
enough
possible
data.
without data. Yeah.
Yeah. So seems like no questions. Just thanks a lot.
Yeah. Thank you. Thank you. And yeah, have a great weekend, everyone.
Yep. Thank you for joining